Thank you for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week, we discuss technologies used in automation. This week, Don Labriola, president of QuickSilver Controls, is here to discuss the Mosolver. Thanks for joining us today, Don.
Thank you much for having me.
Don, what is the Mosolver?
Mosolver is a motor actuator that includes its own feedback internal to it. So Mosolver comes from a contraction of motor and resolver because it's really a combination of the two. We intercept some of the magnetic field that's used to drive the motor in order to determine its position. So we're using the same magnetic structure both to move and to sense the motion.
Okay. So how does that? I guess what's the closest comparison you can apply there? You talked about it being a motor and a resolver. What kind of motor would you compare it to?
What you're resulting in is what's called a hybrid servo now. If you take the same motor and operate it open loop, you'd call it a micro stepper.
Okay.
But with a standard servo, if you took what you'd consider as a conventional three-phase servo and you don't have feedback on it, you just call it a three-phase synchronous motor.
Okay.
So what makes it a servo is the fact that you've got feedback on it, and that completely changes the performance of both of those motors.
Okay. So this is motor and feedback built into one device. What kind of advantages does that give somebody?
Well, from our experience in there, especially on the smaller motors, the feedback device can cost as much or more than the motor itself and is the most sensitive to environmental factors portion of the package.
Okay.
So you end up having to protect it. You have to pay a significant amount for it. And you have to go through and provide room in your packaging for it. So in the case of the 23L1 that we just went through and put together in the Mosolver format, it is almost exactly half the length of the same motor with encoder and protection on the back of it.
Wow. So typically you would take a stepper motor, put an encoder on the back. The encoder then needs to have a housing or something surrounding it to keep it protected. And now you've eliminated all that extra and it's just built into the motor.
It's built into the motor. It's a small flex circuit that actually sets inside the gaps in the teeth of the stator. So it's literally in the same footprint as the motor. It's got all the motor surrounding protecting it. You have to the motor would be destroyed before you could get to the sensor. And you don't have the dust issues. It's magnetic.
Interesting.
You just have a much more robust system in there while also being smaller. And
So you can fit this into tighter designs. Sounds like there's cost benefits to using this type of motor. Um, any additional is the resolution equal to what people would typically see in an encoder, or I know that that's kind of a flexible thing. You can get an encoder in different counts per revolution, but is the Mosolver up there in terms of accuracy?
well, we're seeing about 32,000 counts per revolution out of it.
Wow.
So that is doing very well versus the inexpensive encoders. So that's the end of the market we're looking at is, moving up from steppers. How do you move up to a closed loop without having the cost skyrocket in there? And the encoder was a large portion of the cost, and the other piece you had to pay was the size. So we're able to fit in the same footprint as open loop steppers that we're replacing, but we're able to go through and bring them up to 3 or 4,000 RPM. We're able to handle 100 to 1 inertial mismatches, 10 to 1 very easily, 20 to 1 very easily, 100 to 1 with slight tuning, and a couple thousand to 1 if you work at some. So we're able to handle wide inertial mismatches. We're able to go through and do all the nice things that'd be very difficult with an open loop stepper in the same footprint size.
Wow. So what are some applications, I guess, that maybe you've used this on or that are a great fit for this type of motor?
The hybrid servo that we've been in, and that we're just rolling out the Mosolver as a new hybrid servo that goes through and should fit the same style of applications. except taking advantage of a little more robustness and smaller size and cost. But we've had these anywhere from making tortillas to uh, bomb sniffing devices to we've got some on test fixture for Joint Strike Force for their anti-skid to making Dixie cups, uh,
Wow.
processing hard disk drives, semiconductor polishing for the copper overlays that they put on them. I can keep going.
So, so it sounds like anything that you would have typically wanted to have a closed loop servo type control on, um, a stepper that you've been using that you would actually now want to close the loop. Anything like that is really a good fit for these. It sounds like.
Well, it's actually a fit from both directions, both from the low end servo, low power servo, and a step up from the steppers. So we are sort of between the two and reaching into both of them. The
Interesting.
nice thing about a stepper motor is it has a very high torque constant, very high. Well, they actually call it a quality factor, which is torque per square root of watt. So it's how much power you take to hold it. The motors that we have, you can hold 100% torque on them all day, maximum torque. If you do that on a conventional three-phase motor holding maximum torque, it's either greatly reduced or you've melted the motor. They
Hmm.
typically will run 3 to 10 times continuous current to get the same torque that we produce. So if they're running 10 times continuous current, they're only good with I squared R for about 1% of the time being able to do that.
Wow.
So half a second out of a minute, roughly. So if you go through and type of motors we're using with a very high torque constant, they'll do that all day long and without having an issue. We're just running the same current through them as you would as a stepper motor, and they do that all day long. It's just we go through the way that we commutate, we get optimal torque per current, and we also get rid of the low frequency and mid frequency resonances. So we're able to ramp these things smoothly up from stop up through 4,000 RPM with very smooth motions. They're also very well mapped to lead screws and direct drive belt applications. We can usually get rid of the gearhead.
Hmm. Interesting.
They're also mapped in speed range. One of the ones that just had an article of comparing with a typical servo motor, they have a relatively constant torque up to 5,000 RPM. A lead screw, you typically are only running somewhere between 900 and 1,500 RPM. So if you average that at 1,000 RPM, you're only using 20% of the power of that motor. So you're buying a 500-watt servo in order to get 100 watts out of it.
Hmm.
The motors that we have having a much stronger torque curve at the bottom, we're able to get into the 100 watts with a 100-watt servo. So for some of the belt drives and other applications where you're running at lower speeds, with a conventional servo, you're either having to buy a gearhead to slow it down,
Yep.
and those are not inexpensive and are also a wear item,
Yep.
or you're buying a servo 5 times the rating of what you wanted. So it really does map from both directions very well.
Wow. Interesting. Okay. It sounds like there's a lot of good places to use this then. So, great. Well, I guess given that, anything else that you wanted to add? I think we're running out of time for this week, but
Uh, we will be looking to extend it down in size in some of the areas where it's hard to actually get encoders of decent resolution without a NASA budget type of thing. Uh, we believe this will extend down into at least 11 frame and hopefully into 8 frame motors.
wow. So some very small servo type motion.
Yes.
Interesting. Very cool. Well, great. Well, thanks a lot for joining us this week, Don. And thanks to everybody for listening to Brenner-Fiedler's This Automation Life. If you have any questions about what you just heard, or if you have a topic you'd like to hear discussed, please email us at tech@brfa.com. That's TECH at brfa.com. And be sure to continue tuning in each week.